class 9th students, and welcome to one of the most important videos of your class 9th, which are going to give you a lot of marks in your exams and is also very important for your future studies as well, right? I'm your Aditi ma'am and welcome to Deeksha Vedantu, and in this video we are going to look at all the graphs very quickly and all the important points and their relationships as well that you need for specifically your examinations. Okay, let's start with understanding some basic concepts, right? So main concepts that you will be needing in these videos will basically be, first you need to have a clear understanding of what a uniform motion is, that is equal distance traveled in equal interval of time. Then you must have the knowledge of what a non-uniform motion is, that means unequal distance traveled in equal interval of time, and obviously at rest, that means we are not traveling. So these are three most important things that you need to know. Now basically what we are going to see, like this bus and there is this scale, and we are going to deal with scales a lot in graphs. Okay, these graphs are also important for your future studies as well, because in science, as you go deep in science, you will see graphs have a lot of importance. So this is the foundation, understand them very carefully. Okay, now you just have to do nothing. If the bus is moving, it will from A point, it will go to the B point, or directly to C point, directly to D point. So all these studies we have to do, we have to take an object, put it on a scale, and that is our graph, and see how it happens and relates to the graph. Okay, now starting with the graph, the very first is distance time. Now bacha, see, distance time and displacement time, if somewhere it's written that it's a distance time graph or displacement time graph, will there be any difference between those? For the starting, there won't be much difference, just that distance gives us speed and displacement gives us velocity. Distance is the actual path travel, displacement is the shortest path travel. The only difference is we'll see in this part. Okay, so be there with me. Okay, now the very first is at rest, so I'm not moving, but the time is moving. 1, 2, 3 seconds. So the time is moving, but I am still at, let's say, 30 point, or I am here, this is a 0 point. I move to 10 point, let's say this 10 unit. Okay, I move 10 meters. So now my position is at 10 meters. If I now start the watch, but I'm still not moving, so I am at rest, right? So the graph for at rest can either be at 0, that you haven't started moving at all, or you started moving and you stopped at 20 meters, but now you are not moving. So you are at 20 meters, but now you are at rest. So for that, we will have a straight line. We will have a straight line of graph, and it is not inclined. Understood? Very easy. Uniform motion means equal distance in equal interval of time, right? We have uniform motion means equal distance in equal interval of time. Now what that means, I was at 0 second, at 1 I reached 10 meters, second, at 2 seconds I reached 2 meters, at 3 seconds I reached 3 meters, at 4 seconds I reached 40 meters, sorry, at 5 seconds I reached 50 meters. So you see, I'm traveling equal distance, that is 10 meters, 10 meters, 10 minutes in equal interval of time. 1 second, 1 second, 1 second, 1 second. Now for this, the graph will come out to be a straight line. Okay, so you should draw these graphs with the help of on the graph paper, I'll say, but still with the help of scale. Okay, so your points will be equally displaced when you draw it on a graph paper. Okay, but it will be a straight line. Now next, non-uniform motion. Now for distance, non-uniform motion is, in first second I travel 10 meters, in next second I travel 20 meters. Okay, and in the next second I am at rest. So at 3 seconds I am still at 30 meters. At 4 seconds I reach to 50 meters. Okay, so here is what is happening. I am not traveling in a straight line. It is changing continuously, right? So this, for uniform motion, the graph is a straight line. So if someone asks that distance time graph is showing a straight line, which motion is it? Then that is uniform motion. it is not a straight line. If it is not a straight line, then it is a non-uniform motion. One thing you have to take care of, for distance, the graph cannot come down. Okay, the graph cannot come down for distance, but for displacement, the graph can come down, that is displacement. It can come to 0. I started from here, I went here, okay, this is 2 meters, and I come back. So the total distance I traveled is 4 meters, but displacement, it is 0. It came back to 0. So I reached this point and I went back. So this displacement will now be 0, correct? So distance cannot be negative, displacement can be negative. Understood? And we are done with distance time graph. Let's move quickly on to velocity time graph. Now velocity time graph is very tricky. We have 5 cases. Let's understand. At rest, if I'm not moving, my velocity will be 0, correct? So for this, you cannot draw this, that I am traveling at 30 meters per second, so I'm not at rest, right? You have to draw at rest for velocity should be 0. The x-axis, that means the velocity, should be 0. Okay, so your graph will be on the x-axis. Then now uniform motion. Uniform motion means constant velocity. It means constant velocity. That means my velocity is not changing. I am traveling at 20 meters per second, and after 5 seconds I am still traveling at 20 meters per second. Okay, so this is 20 meters per second. At 1 second I was at 20 meters. At 5 seconds I am also at 20 meters. So what will be the graph? The graph will simply be a straight line, and this is a constant velocity. The graph will again be a straight line. Understood? And it will not have an inclination because my velocity is not changing. Okay, now coming on to non-uniform motion. Non-uniform motion means that my velocity is changing. Now non-uniform motion means unequal distance in equal interval of time. If distance is changing, velocity is also changing, right? Because we know velocity equals to displacement upon time. If my displacement is changing, then velocity will also be changing, right? So I am traveling at 10 meters per second and I'm going with my friend and I'm like, speed up bro, and he goes. In the next second we go to a speed of velocity of 30 meters per second, and then I'm like, no, it's too fast, come down. So it's like, okay, I'll just stop, you drive. So at next 2 seconds we'll come back to 4. Now what is happening? The velocity is not constant. It is increasing, it is decreasing, it is coming back to 0 even, right? I started, I came back to rest. Okay, so this is again not a straight line. Done. Understood? So velocity is changing. Okay, next we have 2 more graphs of velocity. These are very important. Uniform acceleration. That means my velocity is changing, but it is changing at the same rate. That means the change in velocity and change in time is constant. Let me understand. Let me teach you. Uniform acceleration. Okay, now you are going and you're like, bro, let's do one thing. First we'll drive in 4 seconds, we'll drive to 10 meters per second at a speed of 9 meters per second. Then we'll increase it to 20 meters per second in the next second. So at 2 seconds you are 20 meters per second, right? At 1 second you are traveling at 10 meters per second. So at 2 seconds you are traveling at 20 meters per second, and you're like, now increase more. So at 3rd second it's also 30 meters per second. 4th second 40 meters per second. So now you understand that you are increasing the velocity. Equal increase in velocity in equal interval of time will be your uniform acceleration, and the graph will be a straight line. The graph will be a straight line. Now understand the difference. This is uniform motion, a straight line, but velocity is not changing. Here velocity is changing. It was 10, then 20, then 30, then 40, but it's a straight line, but it has an inclination. Inclination means it is inclined with the x-axis. Okay, it is not parallel to x-axis, right? Then comes non-uniform acceleration. That means my velocity went to 50 meters per second in the first second, came back to 20 meters per second, then it remained at 20 meters per second for next next 2 seconds, then it came back to 0 meter per second. Okay, so we started at 0. Okay, I was at rest. Then in the first second, I speed up. I go to 10 meter per second. Then I go to, okay, no, this is the perfect speed. Let's remain at 10 meter per second. And like, bro, speed up. So in the next second, we reached directly to 30 meter per second. And I'm like, no, it's too much. Come back to 20 meter per second. So now you understand, this will be your graph. Understood? This will be your graph. Now, see, this increasing part is what? This is called acceleration. We know, right? When the velocity increases, it is called acceleration. But it is also decreasing. So the decreasing part will be retardation. We have studied it, right? Acceleration and retardation. If you want a detailed video of this whole chapter with graphs and all the equations of motion with numericals, there is a video of one shot of this chapter uploaded on the channel. I will put a link in the description. Go watch that and clear all your doubts. Okay, now here also see, uniform acceleration, it is increasing, but it can decrease also. We come from 50 to 40 to 30 to 20 to 10, right? So this can also happen, and this will be your acceleration, this will be your retardation. Understood? Understood? Easy. Graphs are easy. Okay, you understand now? Okay, now let's do some of the relationships that are very important, and questions will definitely come from these relationships. Okay, now let's see acceleration. We have VT graph. We are given VT graph. We have to find acceleration. One thing that you have maybe studied or not is slope. What is slope? It is the inclination of this. That means this theta. Okay, if I draw this, so theta is this. So this theta, yellow theta is bigger than green theta, right? So this is the slope. So we'll say the slope of yellow graph is more than slope of green graph. Okay, how do you find this? You draw a normal from the end of this graph to x-axis. Now this y-axis, this is y-axis, right? And this is the distance of x-axis. So slope will simply be y component divided by x component. Here y component is what? V, and x component is t. Y component is v, x component is t. So slope came out to be v divided by t. Understood? This is clear, right? Now see, acceleration is what? Acceleration, my friend, is velocity upon time. So acceleration is also velocity upon time. Slope is also velocity upon time. Can I compare these two? That means acceleration is equal to slope, but we have to write off which graph? So this is slope of VT graph. Slope of VT graph. One thing that you have to take care of, that time will always be on x-axis, and the distance, the time, velocity, even the acceleration comes on y-axis, but time will also be in the x-axis. Okay, next relationship we have velocity, but now the graph is, this is displacement time graph. This is displacement time graph, and this is meters. Okay, now again displacement time graph. Let's see what's the slope of it. What's the slope of this graph? Slope of this graph is, ma'am, y component by x component. Y component now is d. Y component is d, x component is t. That means slope is d upon t. Understood? Now what is the actual formula for velocity? Velocity, my bacha, is displacement upon time. Correct? That is d by t. So velocity is also d by t, slope is also d by t. Comparing these two, I'll get velocity is equal to slope of which graph? Slope of displacement time graph. Easy. Understood? So whenever they gave you a graph and the graph is of displacement time and they ask you what will be the velocity, so you will directly write velocity is equal to slope. Slope is simply y-axis by x-axis, that is distance by time, and I'll calculate distance by time. If they ask you to calculate the velocity, they ask you to calculate velocity between 0 to 4 seconds, okay, 0 to 4 seconds. So what will you do? You will find the slope. How will you find the slope? The slope will be equal to y-axis by x-axis, but we have 0 to 4. So till here, the change in time will be what? 4 minus 0, that is 4 seconds, right? And the y-axis, it will be 0 to 40 meter. Right? So the distance will be 40 minus 0 will be 40 meters. So D comes out to be 40, D comes out to be 4. You just have to divide them. Slope is D by T. D comes out to be 40, T comes out to be 4, and 10. You will say, ma'am, slope is 10. That means velocity is 10 meters per second. Understood? How to solve the question even. Okay, the one relationship that is left is your displacement and velocity. What is the relationship? See, we had VT graph here as well, but we needed to find acceleration, its relationship with acceleration. Now we also have VT graph, but we need to find its relationship with displacement now. So let's say, what will be the slope of this? What will be the slope of this? Since we calculated slope, that is y-axis by x-axis, y by x, that is velocity upon time. That is velocity upon time. But displacement is not velocity upon time, right? It's distance into time. Correct? So velocity, I said something wrong, right? Okay, this is, we have to find displacement and velocity. Let's say, what is the, see, this is the relationship we have. Slope is V by T. Now, velocity is equal to displacement upon time. Is that true? Velocity equals to displacement upon time. I did say true. What happened? Sorry for that. I got a glitch in the matrix. Okay, so velocity is equal to displacement upon time. Now, if I calculate displacement, that is equals to velocity upon time, because here I need displacement, right? So I calculate displacement, that is V into T. But here we have V divided by T, so we cannot relate them now. Now comes the fun part. See, if I drop a normal at this point, okay, or any point, so what will happen? This part, what is the area of this part? What is the area of this part? This is a rectangle. The area will be length into breadth. What is the length? Length is T. Correct? Length is T, and breadth is what? Y-axis. Length is x-axis. Okay, and y-axis is our breadth. Correct? This is area. So area comes out to be, what is on x-axis? Time. What is on y-axis? Displacement. Oh, sorry, velocity. We have velocity. Now, can you equate this to velocity into time? Velocity into time. That means displacement is actually not equal to slope of the graph. It is equal to area under the which graph? This is a VT graph. This is a VT graph. Understood? And see how we saw. We tried with slope, but we didn't get any outcome. So we tried area under the graph. That means if you want to find displacement for a VT graph, you have to find area under the VT graph. If you want to find acceleration from VT graph, you have to find slope of the VT graph. And that, if you find velocity from displacement time graph, you need to find slope. Understood? That is it. We are done with all the graphs. Those are all the graphs. Those are all the relationships between these graphs, and a lot of questions can come from this chapter. And this is the basis of, what do you say, your future science expeditions, right? So make sure you understand these graphs very carefully. If you have any doubt, let me know in the comment section. I will address in the next video, or I'll come live as well, so you can ask there as well. Okay, that is it for this video. Make sure you subscribe the channel. There will be a link in the description. Go join that WhatsApp channel as well to get all the notifications. And this is your Aditi ma'am. Tata, bye bye. I'll meet you in the next one.